Statistical Rethinking, second edition, chapter 14. We're in the medium difficult questions, number 14M2. Okay, I think before we start this, let's just jump back to 14M1. And in that problem, we generated some data. Well, actually, the book generated some data at the very beginning of the chapter, and we copied and pasted it, where a robot is going around, checking to see how long it takes different cafes to get a cup of coffee. And then part of what we did in the previous question, as well as what happened in the chapter, was we modeled that by doing a lot of little tricks, but among them was to allow for correlation between parameters, in this case the intercept and the slope. Okay, and the way that we did that is we put those parameters into a multivariate normal distribution that had a correlation rho, and we estimated rho with this LKJ correlation matrix. Okay, so now in 14M2 we're going to fit the same data but to this model, and notice that this model is not going to estimate correlation among the parameters. Now in this case we happen to know there's correlation among the parameters because we built the data to make sure that there was. Okay, so we're going to fit this model, which again is different than from the previous problem, and then we're just going to compare them with WAIC. Okay, so this first part is just copied and pasted again from the previous problem, okay, which is also copied and pasted from the chapter. Okay, so this is how we generate our data, and again notice that we have a correlation among the parameters of negative 0.7. Okay, and so now I'm just going to refit the chapter model. Okay, this is the one that that allows for correlation among the parameters, and then I'm going to fit the hierarchical model that we are asked to fit with this question, okay. And then run it, and then compare them with the compare function with WAIC. Make sure that if you're going to do that, that you include the log like equals true argument in your models here. Okay, and so when we do this, this is our output from the WAIC compare function, and you'll see that that the first model, the model in the chapter, the model which allows for correlation among the parameters, is taking about 2/3 of the weight, so it's doing better at fitting the data. Well, how do I want to say this? That's not exactly the right thing to say. It is receiving a better estimate of its ability to predict new data. Okay, so that's a better way of saying that. Okay, and so apparently what is happening here is that the correlation inherent in the data, which again we know is there because we built it into the data, by capturing that, even though it is more parameters, which should penalize this model more than this model, it's doing a better job of representing the data, and so it is preferred apparently, or at least it's weighted more heavily between these two models. When we don't account for that correlation structure, as we didn't in the second model, we are apparently suffering. Our model is suffering a little bit in terms of its ability to make accurate predictions, or estimated to make less accurate predictions. Okay, so we would call that good.